Hello everybody, and welcome to our class video where I will give you an introduction to trigonometry. Our learning goal is that you'll be able to use trigonometry to calculate an unknown length in a right triangle. This will give us one additional strategy that we can use to find unknown lengths in addition to the Pythagorean theorem and special right triangles. Now, in order to understand the basics of trigonometry, you need to know the names of the three sides of a right triangle. All of these are relative to the location of a specific angle, which we will call theta. Theta is a Greek letter, and it is usually used in math to signify an angle. So, there we go, we have our angle theta. Now you already know the name of one side of a right triangle. No, for the last time, it is not called the hippopotamus. It is the hypotenuse. Get it right. Okay, see you later, hippopotamus. Alright, so that side is the longest side of the right triangle, and it's always across from the right angle. That side never changes. The other two are relative to where my angle theta is located. Okay, so across from the angle theta is the side called the opposite. Okay, opposite means across from, like if you're on the opposite side of the room from me. So the side opposite from theta is called the opposite. The other side, the one that's next to our angle theta, is called the adjacent, because the word adjacent means next to. So we have the hypotenuse, the opposite, and the adjacent. Now, it does matter where my angle theta is. Let's say I'm referencing everything from the angle at the top of the triangle rather than the one at the bottom. So if my angle theta is up there, well, the hypotenuse is still the hypotenuse, and I'll just abbreviate it HYP. Alright, but the other two sides change. Now the bottom side is opposite from my angle theta, and the adjacent is the vertical leg. So make sure you pay attention to where the angle is located. Alright, so these three sides of a right triangle form the basis for three basic trig functions. We'll define these with our old friend, the 5, 12, 13 triple. Okay, so the first thing you need to do in pretty much any trig problem is label the sides. So based on where our angle theta is, I've labeled where the opposite, the adjacent, and the hypotenuse are. The three trig functions are called the sine, the cosine, and the tangent. Or often we abbreviate them with sin, cos, and tan. However, you still say the entire name. You don't say it as sin, you say it as sine. And you don't say cos, you say cosine. Okay? After each of these trig functions, we write the angle. So here I'll write the angle theta. Each one of them is defined as a specific fraction of the other sides, or a ratio is a better way to put it. So the sine is the ratio between the opposite and the hypotenuse. So sine of the angle is equal to the opposite divided by the hypotenuse. In this case, it would be 5 over 13. The cosine is defined as the adjacent over the hypotenuse. So for this triangle, it would be 12 over 13. The tangent is the ratio between the opposite and the adjacent, which in this case would be 5 over 12. Notice, of course, if the angle theta had been in a different location, my opposite and adjacent would have switched, and that would change the values of these functions. Okay, but these are just a ratio between two of the sides of the triangle. Okay, so now how can you keep this all straight? So we've got these three functions. How are you going to remember them? Well, there's an old acronym that has been around for a long time, is pretty popular, and it's Sohcahtoa. It sounds like the name of like some Native American chief or something. Now, I don't know that that's actually a name of a historical Native American chief. We're just making that up, but it just sounds like it. Maybe he's from a tribe that hunted hippopotamuses or something, or would it be hippopotami? Oh, I don't know. Okay, forget it. But notice in the acronym here, Sohcahtoa, that the S stands for sine, O for opposite, H for hypotenuse. So sine is opposite over hypotenuse. Likewise, cosine is adjacent over hypotenuse, and TOA tells us that tangent, is equal to opposite over adjacent. Okay, so, alright, that's a way you can keep it straight. I won't have these formulas available for you on the test. So, let's get used to memorizing them. Alright, so now let's look at an example of how these are applied, now that you know the basics. Alright, let me walk you through the steps. The first step is to label the sides of the right triangle with opposite, adjacent, and hypotenuse. Okay? My x here is the opposite because it's across from the angle of 34 degrees. The 9 is the hypotenuse because it's across from the right angle. Okay, so the second step is to pick the appropriate trig function for this problem. I'll write the acronym out, Sohcahtoa, and just for your reference to make it easier to see, I'll go ahead and write out each of the three functions. You wouldn't have to, but you've already got them on your paper, so just follow along. Alright, so we need to pick the trig function that's appropriate for this problem. The sides that we have labeled in the picture are the opposite and the hypotenuse. So which one of the trig functions uses the opposite and hypotenuse? Oh, that would be sine. So that's the function we'll use for this problem. I'll erase the others. Okay, so we're going to use the sine function. The next step is to fill in that equation. My angle theta is 34 degrees, so I'll change theta to 34. Then I need to fill in the ratio. The opposite side is x, so I'll write that on top, and the hypotenuse is 9, so I'll put that on bottom. Okay, I filled in the equation. The last step is to calculate the trigonometry value and to solve. Alright, so the sine of 34 degrees is some specific decimal number that you can find using your calculator. So this is saying that any triangle that has a 34-degree angle always has the same ratio of the opposite and hypotenuse. The opposite over the hypotenuse will always come out to be 0.559192, blah, 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 blah. Okay? So I can replace the sine of 34 degrees with that decimal number. I'll round it to 0.559. Then I just need to get x by itself. I need to solve. How would I get x by itself? The opposite of dividing by 9 is to multiply by 9. So if I multiply by 9 on both sides, then I would get x by itself. Now here's an important point. Whenever I multiply the 9 times the decimal value, I want to keep all the decimal places to have the most accurate answer possible. For this reason, make sure in your calculator that you use the answer function to do answer times 9, so you're using all the decimal places in the calculator. Therefore, I can say that my answer, that side x, is 5.03. Okay, so before we go to the next example, here's something else that's very important. Your calculator absolutely, positively must be in degree mode. You can change it to degree mode by pushing the mode button on your calculator. This is very important because the calculator defaults to radian mode. If it's not in radian mode, then I guess you'd be good because you'd be in degree mode. Never mind. I said that wrong. But anyway, so make sure you're in degree mode. Alright, so let's look at our last example. I'll walk through the steps one more time so you guys can get a good idea of what's going on. I'll write you already got the steps written down, hopefully, but I'll write them down here just for your reference as I go through the process. Okay, so first we need to label the sides. The 2 is the adjacent because it's next to the 60 degrees, and x is the hypotenuse. Okay, so we need to pick the appropriate trig function for this problem. I have the adjacent and the hypotenuse labeled on this triangle. Which of my trig functions uses the adjacent and hypotenuse? Well, which part of our acronym, Sohcahtoa, it uses A and H? Oh, well that's the Ka part. So Sohcahtoa has CAH, so that means I'm going to need to use cosine function for this problem. Okay, so let me fill in the equation. The angle theta is 60. the adjacent is 2, and the hypotenuse is x. I can figure out what the trig value is by putting cosine of 60 into the calculator. In this case, it's just the simple decimal 0.5. Most of the time it has a lot of decimal places, but this one is actually very specific. Okay, so I have 0.5 equals 2 over x. Oh, now my x is in the denominator. How can I take care of that? How can I solve for x? Well, just like we did before, let's multiply both sides by what's in the denominator. This will remove the denominator so that I have 0.5x equals 2. Okay, so now I just divide both sides by 0.5. If this were any other decimal than 0.5, I would definitely need to make sure that I put 2 divided by the answer in the calculator. That way I used all the decimal places there. But in this case, we'd still get the same answer that's 4. Okay. Hey, did you notice? This must be a 30, 60, 90 triangle. And this triangle, with the answer that we got using trig, follows this 30, 60, 90 formula triangle that we just talked about before. So this is a verification that trigonometry gives us the correct answer. Alright, so happy hunting some hippopotamuses, and I'll see you guys in class.